Hello everyone, and welcome to this basic tutorial, this very basic tutorial on programming in Matlab. I will talk a little bit about how to begin, and then we will go over and do some examples in a short, very basic Matlab program that I've put together for you. So let's get started. Alright, so we will use Matlab in BNG312 to model some bioprocesses. And from the last homework, Matlab is a programming language. It is a powerful tool, and as engineers you should have familiarity with it. It can be very useful for things that we do, both in class and in your careers as bioengineers. The idea of this online class is to get you started in writing simple programs, and the assignment at the end will help you with that, and we'll do it a couple of different ways, and I'll talk about that in a minute. Matlab is available on the Computers and Textiles 219. Hopefully by now you all know where that is. Alright, so we can use Matlab as a calculator, we can use it to write programs, and we can use it to answer questions using the programs we write. Matlab as a calculator is pretty self-explanatory. I won't go over it. You essentially just type in functions, numbers and functions, make little equations, and Matlab will solve them for you. Writing programs, we will deal with that here, and we will also deal with, especially for this little video lecture here, we'll deal with answering questions using programs that have been written. And there are tutorial videos. You don't have to watch them. They're very helpful, however, so I would suggest you watch them if you have the time. Alright, so if you open Matlab, this is what the home screen looks like. There are a bunch of different little windows here. You've got a current folder window, which tells you what folder you're in, what folder your Matlab program is in. You have a workspace, which will usually tell you how your variables have been valued. You know, what is the value of all your variables that are involved in the program you're using. And then there's a command history, which will tell you all the commands, give you a history of all the commands that you've done in your command window. And here is your command window, which you will actually type the commands in. So you could actually type 1 + 1 into the command window, click enter, and you would get 2 as the response. So beginning to write programs. So when you get to doing your assignment for this online class, you will at one stage click the new button to start a new program. And this will open the editor and it will allow you to write down the code in the editor, and then you can save it. You can save it as a .m file and then run it. And so we will actually look at a small program that has been written in this way. It's what I call the bacterial growth program, and basically what this does, it has a couple of different equations here that will allow you to input the initial number of bacteria, which the variable I've indicated for that is NO, and it'll allow you also to input the number of generations, which is G, and from that we can get the final number of bacteria, or NF. We could even use this to calculate the generation time using NF and NO if we wanted to here. We've got two different equations here, one which we can find the value of NF, and one which we can find the value of G. So I've made these initial variables, NO and G, have had values set for them. NO arbitrarily is set at 1. We will change this in just a minute. And G is set at 10, which again we can change that in just a minute. So you can see I have a lot of lines that begin with a percentage sign. These are all comments. You can see right at the top here it says this is a comment. I recommend when you are writing or inputting programs into the editor, you comment a lot You comment early, you comment often. That way you know what's going on, especially if you have to save it and come back to it and finish it up later. You know what's been going on. This really helps you get things in order to try to figure out what you've been doing. So, and you can see here I've kind of made notes for myself and for whoever might use this little bacterial growth program as to exactly what we're doing here. Things like, what is the significance of this number here? And I say that, well, the log 10 of 2 is 0.301. That's why we see this here in the G equation. So you can see this program, the bacterial growth program, here in the editor. Here it is in the editor here. Here's the editor window, which is separate from the home screen with the command window. So when you click new, basically this pops up, this editor window pops up, and from there you put in your program that you're going to write and save. And then you can click this little green arrow button, this run button. Looks kind of like a play button on your CD player or your MP3 player, and you can run the program. And I'll show you how that works. So initially, after you run the program, you can check the value of your variables. So if I was to run the program, the bacterial growth program, I can type in NO, and the Matlab would spit back out at me NO equals 1. I can type also NF. We're looking to find NF in one of those equations. It'll give me the value for NF. NF equals 1.0007 times 10 to the third. And G is roughly 10. Okay, so let's now use this program to answer some questions. So I have it queued up here, and I will get to that in a minute. But what we are doing is we're growing the industrially significant organism, Corynebacterium glutamicum, in the lab. You determine that the number of cells in your flask when you start the experiment was 12,000. So you start with 12,000 cells. So we already have one variable defined. How many C. glutamicum cells will be present in your flask after 12 hours of culture time? The generation time is, if the generation time is 35 minutes. So we're going to assume unlimited food in a clean environment, no contamination. So we're just growing our C. glutamicum, and they can grow indefinitely. So first we have to know our variables. So we've got a lot of information here. What was given? So in this question, what was given? We have NO. Yes, we have NO. NO is 12,000. Do we have NF? It seems like that is what we're trying to find. How many cells will be present after 12 hours? That would be our NF. G. G is number of generations. We don't quite have that, but what can we calculate from what we have been given here? So we know NO is 12,000. G is the number of generations. And to calculate that, we would use the time of experiment and divide that by our generation time. That would give us our number of generations. So the time of the experiment is 12 hours or 720 minutes, and we know from the question that our generation time is 35 minutes. So we just take 720 and divide by 35 to get 20.6 generations. So that's our, so we know NO and we know G, and now what we want to do is find NF. So we can do that here. Okay, so here I have Matlab open to this bacterial growth program, and you can see here that I have the command window in the home screen here. I also have the editor window open, and our bacterial growth program is queued up. So we know our NO. We learned that from our question. It's 12,000, so I'll change that. And our generation time is not 10 anymore. It's 20.6. So I'll change that as well. And now what I can do, I can save it. So I save it. I don't have to save it. I can just hit the run button. So something has happened, but we can't really tell what. But we have to go back to the home screen with the command window here. And you can see this bacterial growth 1 has been written in the command window. that's indication that we have run our program, and we now see in our workspace our variables are defined. So I can type in NO and get our NO, that's 12,000. G is 20.6. And now what do we want to know? We want to know NF. So I can type in NF. You can clearly see it in the workspace over there, but we can get that our NF is 1.9 times 10 to the 10th cells. So we have an answer to our program here, or to what we want to know, our question. So how many C-glutamicum cells will be present in your flask after 12 hours of culture time if generation time is 35 minutes? The answer is that after 12 hours there will be 1.9 times 10 to the 10th cells in the flask, and that is the value of our NF. So we've figured out our NF. So say we alter the question. We can alter the question a little bit, and then we can tweak the program a little bit, and with tweaking the program a little bit we can get some new answers. And you'll be asked to do that with a lot of programs that I'm going to give you over the course of the semester. So we'll be doing this rather a lot, really. So let's see a bit of that in action. So our generation time is slowed down. It's 1 hour and 20 minutes this time, or 80 minutes, and because you're using a different media. But again, you begin your growth experiment with the same amount of cells, 12,000. Again, how many cells are present after 12 hours of growth? So we have our NO, it's the same, it's 12,000, and our G is 720 over 80 this time instead of 720 over 35 this time, or 9 generations. So now we can change our G, our value for G. So we'll go to the editor and do that. We'll change our value for G to 9, and then I'll hit run. It runs. It's changed the value for G. I can already see that. And again, we see that I've hit run. This bacterial growth pops up, and now I can type in a command. Again, I can type in NO. It's still 12,000. G, it's 9. And NF, we can already see it over in the workspace. I can cheat and just do it that way, or I can type in NF, and NF equals 6,144,000. So now we can go back to our question here. How many cells present after 12 hours of growth? The answer is that NF equals 6.14 times 10 to the 6th cells. Okay, so with that small, simple experiment here, our example, we can now move to the assignment portion. So you will read a small file. It says read me first. You'll be reproducing the same graph in an introduction document, which you'll also have as part of this assignment. You'll be reproducing figure 2.3. First you'll do this in the command window, and then you'll do it in the editor. And your deliverables will be proof that you've made the figure, and then proof that you've created the figure using both those methods. So follow the instructions on the document, the read me first document, and then after that you can submit these either by email or via my courses. There are some introductory videos that you can look at. I will post those on my courses. There are 3 tutorials. This tutorial 3 is in 2 parts, but you can look at these tutorials and again get kind of an introductory flavor of what Matlab is like. Good luck, and don't hesitate to contact me if you have any questions on anything regarding this assignment. Thanks.